All right, Addie, hello there, little math genius. I am still freaking out that you got 100% on that last homework assignment. I mean, I can't believe it. I'm glad that that's rare, actually, because if you got 100% every time, I would be like, oh, the stuff I'm teaching you is way too easy. So it's helpful when you miss things, actually. So don't try and get 100% every time. It's totally fine. I want you to get 70, 80%, because these are really, really hard concepts and really, really hard homework assignments. But today is not that bad because we are going to talk about polynomial equations, which you already know all about polynomials. So now we're just going to add the equation portion of it. Then we're going to talk about ordered pairs and then how to put those on a graphing Cartesian coordinate system. Okay, so I don't know if I have shown you this one before, but I get a kick out of it. It's pretty funny because humans have built weapons that can destroy cities and have reached space. Also, humans use the other door. The goose will attack you if you go out through this door. And here's the goose. He looks kind of scary. I would actually use the other door if I saw that, I have to admit. All right, let's jump into what it means to have polynomial equations. So remember what a polynomial is. You have to be in the Pollyanna Club, and so you have to have an x. It has to be in that form. Now, also remember, I want you to remember this part, the degree of a term of a polynomial is going to be the sum of the exponents of the variables. So I'm going to show you that example to remind you of what that means. But remember, when we look at a term, we can say if it's a third degree, first degree, second degree term. And the way we figure out which degree it is you add up all the exponents on the variables. So let's try it, okay? Let's do this one. 2x cubed is going to be a third degree term. And the reason is because of that 3 right there. Okay, let's do the next one, x. X is going to be a first degree term. And the reason is because it's assumed that there's an exponent of 1, and that 1 makes it a first degree term. Okay, what about this one? Remember, it's the sum of all the exponents. So this one's going to actually be a third degree term. Why? Because there's a 1 exponent on the x, 1 on the y, 1 on the z. It's the sum of all those. So if we add up 1 plus 1 plus 1, we get 3, and so that's a third degree term. Okay. Now, what about the degree of a polynomial when there's a lot of different terms in that polynomial? Okay, so the degree of a polynomial, like if we were to pick out the degree of this whole thing, it's going to be the degree of its highest degree term. So it's kind of like all of these have a little competition, and whichever one has the highest degree, that's the one that's going to win. Okay, so let's go through and figure out what this is going to be. Okay, so this one is going to be a third degree polynomial. That's the answer. The reason is because this term gets a 3. This term gets a 2 because you've got a 1 and a 1. And this term just has a 1. So the winner is this 3, and so the whole polynomial is considered a third degree polynomial. Okay, let's do the next one. What about 2x plus 4y? This is going to be a first degree polynomial. Why? Because if you look at this term, it has a degree of 1. If you look at this term, it has a degree of 1. Which one wins? Well, it doesn't matter. They kind of tie. So it's just a first degree. I erased a little bit of it, but that's okay. What about this last one? This is also a first degree polynomial. There's no competition. This one just has a exponent of 1, so this one automatically wins, and it's a first degree. Okay, so we've covered that. Now, the degree of a polynomial equation. Now, anytime you have two polynomials that are connected by an equals sign, so a polynomial here equals a polynomial here, the degree of that polynomial equation is the same as the degree of its highest term. So just like before, it's going to have a competition. It's going to have a competition. And who's going to win that competition? Harry Styles. No, not Harry Styles. Whoever wins that competition is going to be the term with the highest degree. Okay, so that's a new expression for you to know, a polynomial equation. And it just means two polynomials and they're connected by an equal sign. So you've got a polynomial, you've got an equal sign, and you've got another polynomial. Okay, so here are some examples of that. It doesn't look like there's a polynomial on one side, but there is, because you could easily move this to the other side, right? I mean, whatever. This is a polynomial equation. It has an equal sign in it. So let's start with the first one and decide what degree is this going to be. Okay, so let's do this little competition here. You've got, what do we have? We have a 4 on this one here. We have squared. And this one, we assume it's x to the 0, right? Because x to the 0 makes just 1. So this is going to be a 4th degree polynomial because this one wins. Okay, what about this one? Let's move on to this equation. Okay, our first term has 3 exponents. They're all 1. What do we do with that? We make that a 3rd degree polynomial, or 3rd degree term right there. And then this one just has an exponent of 1, so that's 1st degree. So the winner is the 3rd degree, and that's what this whole equation becomes. Okay, what about this last one? Y equals 2x plus 4. Keep this equation in your head for, well, you don't have to keep it in your head, but we're going to examine this equation really closely. What degree is this polynomial equation? Well, it doesn't matter if the x is over on this side or on this side. All of the variables have an exponent. The y has an exponent of 1, so that's 1st degree. The x has an exponent of 1. Okay, this one, the 4 just has kind of an exponent of 0. So this is actually a 1st degree polynomial equation. Okay, now let's look at that equation a little bit more carefully. This is the one I said we're going to examine more carefully. Y is equal to 2x plus 4. We're going to start looking at equations like this with two polynomials, with, a polynomial, 2 variables. And there's an x here and there's a y here. And think about solving a problem like this. And it turns out that this has an infinite. That means no end in sight to the number of answers that this equation, when it's written like this, it can have more than a million, more than a bajillion, more than any, like an infinite number of answers. Why? If you think about it, it kind of makes sense because you could pick any number for x. Like let's say you pick the number 1. And then how would you make this true? You would plug in 1, and that would be 2 times 1 is 2 plus 4. 2 plus 4 is 6. And then the y would be 6. And then you get 6 is equal to 6, and that's true. So if x is 1, y would be 6. And you could pick any number for x and plug that in there and figure out what the y would be, and it would still be true. Let's do a couple more. So here's some that we can put in. Okay, so let's start with this 2. Let's plug that in for x. If we plug that 2 in for x, okay, I'm going to move this up so we have plenty of room. Then you get y is equal to 2 times 2 plus 4. This simplifies to, well, 2 times 2 is going to be 4. Whoops, 4 plus 4. And you get 8. So if x is 2, then y is going to be equal to 8, and that statement would be true. So you've got a 2 and an 8. Okay, that's fine. We got that, right? We understand that. What if we plug in a -5 for x? Let's do that. Let's try it. Y is equal to 2 times -5 plus 4. Okay, now let's simplify. We multiply first. This is order of operations. 2 times -5 is going to be negative 10 plus 4. 4 minus 10, that is just negative 6. So negative 6 is the answer. So if x is negative 5, then y is going to be equal to negative 6. So that still works. That x and that y are going to go together and make that true. And it turns out that you can pick any real number. We haven't talked about not real numbers yet, but we'll get to that eventually. Just think of any real number. It could be a fraction, it could be pi, it could be, 7, whatever. Put any real number in for x, and you will get a y that makes this a true statement. So that's why there can be an infinite number of answers for this equation, because you could put in, starting with 0, let's just do all the counting numbers. 1, 2, 3, 4, 5, 6, 7, 8. If you spent your lifetime doing this, you would never find all the answers. It would take forever because it's infinity, right? Even Harry Styles is amazed by that. Wow. All right, so there's a method that we're doing this, right? So we pick a number for x. Okay, we pick a number. And because we're picking this number and we're plugging that in, that's called the independent variable. That's the one that we can choose. Okay, that's the one where we assign it a value. So independent, we assign a value. We assign it a number. It can be anything. All right, now what we get for y depends on what we picked for our independent variable. Oh, I'm going to sneeze. I'm going to try not to sneeze. I'm plugging my nose. I'm sorry. Oh, normally I would edit that out, but everyone else is in bed and I'm trying to get to bed. So sorry, I had to suppress a sneeze there. All right, so x is the independent variable because that's the number we're going to assign. Y is always going to be the dependent variable. And that means that the answer for y depends on what we chose for x. How do you remember that? Just look at this. The answer for y depends. So it's the dependent variable. Okay. What else do we know about this? Okay. Now, let's see. Oh yeah. Usually when you have an equation with an x and a y in it, just by definition, x is going to be the independent variable and y is going to be the dependent variable. And just think, why do I always have to depend on that? The y is asking, why am I always the dependent variable? But it usually is. Okay, that's just by convention. All right, so let's move on. You ready to move on? Okay, little eye candy there. Let's talk about ordered pairs. So again, we're going to look at this equation. Y is equal to 2x plus 4. Let's say that we let x be equal to 2. Now we already figured that out. When x is equal to 2, then y, the dependent variable, becomes 8. And that means that the 2 goes with the 8 when this is the equation. So if the 2 goes with the 8, we can write it like this, 2, 8. And this is another example where we do it by convention. We put the x first and the y, the dependent variable, next, x, y. And it looks like this, and this is going to be your answer. Okay, remember when we plugged in the negative 5 for x? What did we get? When we plugged in negative 5, then y was equal to negative 6. So that means that if x is negative 5, the answer we get for y is negative 6. And we can write it like this, x, y. This means that x is negative 5, y is negative 6. These two go together. They are called an ordered pair. Those numbers are paired together by this equation. That's kind of cool, huh? So usually when you write it like that, the x value is the first number in the parentheses, the y value is the second number, okay? So x is first. The second number is always going to be y. Sweet. So yeah, just a reminder there. All right, let's move on to the Cartesian coordinate system. Now, remember, back in lesson 37, we learned that whenever you get an answer or whenever you get a solution to an equation, or it could be an inequality, you can graph that answer. Anytime you get an answer, you can graph that answer. This is something you already know. You know it. You know it, baby. Okay? So you know that. So when you get an answer like x is equal to 4, you can graph what that looks like, right? You just put, whoops, you don't do that. You don't do that. You just put a dot where the 4 is. And this is kind of, it's so weird to have a graphical solution like this if you think about it, because what does that dot stand for? It means there's a tiny, tiny point right there where the answer is. And it's like, it doesn't even have a size. It's like infinitesimally small. I did not say that right. You know what I mean. But if you have like 4.01, that's not the answer. That's not the same as 4. So it's like a really small value right there. And the dot indicates where that value is. That's what it indicates, right? So that's kind of cool. Can you also graph another answer like this if you get an inequality? I mean, maybe your friends can't, but you can because you are a math genius. So what this answer would look like if you graph it is it includes the number 2 because of this part of the inequality. You also want anything greater than -2. So anything greater would be like this, and it would look like that. And that's how you graph this inequality. I'm telling you something you already know, but just to make the point that when you get an answer of an inequality, you can graph it, and we've learned how to do that. That's easy. Guess what? Turns out when you get 2 answers, you can still graph that. So what do you do? How do you graph it when the answer has 2 variables? Let's say you have an x and a y, just like this equation that we've been studying, y equals 2x plus 4. When you get an answer, you're going to get an x, right? And you're also going to get a y. We got 2 answers. We got an ordered pair for that. So how do you graph that? Well, you're going to need a 2-dimensional graph. It's not just a line anymore. It's 2 dimensions. It has an x-axis, that's x, and it has a y-axis, that's y. And this graph has a name. It's called the Cartesian coordinate system. And this is divided into quadrants. This is actually the first quadrant. It seems weird that it would be there, but think about if you have a positive x, like 3, and a positive y. So if your number is 3, 3, that's a positive and a positive, you're going to end up putting your dot right there in the first quadrant. So that's why it does make sense to me that it's a that it starts there. The second quadrant is here, and then it goes around in a counterclockwise direction. So first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, now, a couple other things to point out. The x-axis on this is the horizontal axis. If you forget which one has which name, think of the horizon. The horizon, like when there's a sunset, the sun looks like that, like setting over the ocean, right? And the horizon is a straight line left to right. Okay, so this straight line left to right is the horizontal axis, also called the x-axis. The vertical axis, the one that goes up and down, is the y-axis. Okay, you got to know that. So this is always x, this one's always y. All right, and this is called the Cartesian coordinate system, and it's named after this guy, René Descartes. He, as I mentioned before, he's not exactly a looker. I mean, he's not a looker. You know what he is? He's a thinker. He's not a looker, but he's a thinker because he's the one that came up with, I think, therefore I am. So he was a philosopher, and he was also a mathematician, and he was a French guy. And he wasn't very pretty, and his name was Rene. So if he was American, he'd probably get bullied a little because, look, I'm sorry. I don't mean to insult him, but he was a thinker, not exactly the prettiest guy around. I don't think, based on that picture, but I don't know. You might like him. Tell me if you like him on a scale of 1 to 10. Okay, I think, therefore I am. Anyway, let's move on. So as I said before, when we use a single number line to graph the solution, it's just one variable. For example, if I were to graph on this number line, x is equal to 2, I would just put it right there. And this is the coordinate of the point on the line. Okay, the point doesn't have a size. So the graph is not really the point of it. It just shows the location of the point. I don't know. Does that make sense? So if you have two numbers now, if you have an x and a y, you have to use two number lines. You use the x number line, the horizontal, and the y number line, the vertical. And then you're going to put the 2 points on this. The number that is written first is always the x coordinate. That has another name. Look at this weird name. Abscissa. Abscissa. I don't really know how to have you remember that, except that I kind of think that the number x could look like scissors. And look how this is spelled, scissa, like scissors. So that's how I would remember it. The x looks like scissors. So that's the abscissa. And the ordinate is the y number. And I don't know how to remember that one, except it's such a weird word, ordinate, that I would put a y in front of it to remember that the y number is the ordinate number. I don't know, ordinate? I don't know. It's such a weird word, and when it has a y in front of it, it's an even weirder word. So I would just remember the word ordinate. That's just terminology for the x and the y. So abscissa, ordinate. Okay. All right. And then we're going to just practice graphing these. This is example 50.1. And they just want us to graph these different points. And I think that you already know how to do it. So let's do 3, 3. Let's start with this one, 3, 3. So if I were to graph that, I would start with the x, go over 3, 1, 2, 3, and then go up 3, 1, 2, 3. So the point is going to be right here. This is 3, 3. Okay? All right, so we did that one, no problem. Let's do the next one. It's -4, 0. So we're going to do that purple one. So if I were to graph the purple one, I would start with the x, which was -4. Okay, so -4. 1, 2, 3, 4. And 0, that means I don't move anywhere on the up and down. Okay, so I'm going to put it here, and this is -4, 0. Okay. Alrighty, let's go to the next one, and the next one is 0, -3. 0, okay, I'm going to use green for that. 0 means you don't go anywhere left to right. So I'm just going to stay, oops, messed up there. Okay, so I'm just going to stay on the 0. And the next number is -3. So I'm going to go down 3. 1, 2, 3. And I'm going to put my point right here. So this is 0, -3. Okay. Actually, I'm going to move this, and you'll see why in a second, because I have to put my last point there. The last point is 4, -2. So I'm going to start with the x. I'm going to go over 4, 1, 2, 3, 4. I'm here. And then I'm going to go -2, 1, 2. So I end up here. So this point, oh, that's not the right color. I think it was orange. Orange. This is 4, -2. Okay, so you see that you can graph everything on a Cartesian coordinate system. You could probably say which quadrants they're in too. This is the first quadrant. Second quadrant is here. This one's not really in that quadrant. It's on the line. This is the third quadrant. This is the fourth quadrant, right? This one's also on the line, so that doesn't count. But this is the fourth quadrant. Okay, that's it, Addie. Guess what? You are going to do awesome on your homework today. Don't get 100%. I mean, make me feel like you're learning something, but get close to that. All right? Love you, Addie. Have a great day. Bye.